So next up, we have Alexander Shapkin, who is a software engineer at GridGain. He is going to talk about deploying Apache Ignite in the cloud, and we're going to have a checklist. So hopefully everyone will be able to repeat his success next time. So over to you, Alexander.
All right, thank you, Stephen. Wait a second. So I think, yeah, we're ready to go. Hello and welcome. My name is Alexander Shapkin, and today I would like to talk about some tips and tricks for running Apache Ignite or GridGain clusters in Kubernetes. We are going to check some recommendations and common issues that you might encounter running your cluster in a cloud. As a result, you'll have a complete checklist that you can follow to verify your deployment. A few words about me. Currently, I work as a software engineer at GridGain company, and I have a moderate experience in software development and databases. Here is the agenda for our talk. We are going to start with simple themes like deployment model and networking, and then move on to more specific items like disks and GridGain Operator. All right, let's start with deployment model and explore what Kubernetes workload resource to choose and how to organize the pods. There are two mostly used workload resources, depending on whether you are running a stateless or a stateful application. The first one is a deployment resource, and in respect to Apache Ignite, it has the following limitations. Well, your pod's names are being generated randomly and are replaced after a restart. That means you cannot configure a consistent ID properly. We'll talk about it later. And since the deployment resource doesn't have volume mounts, you cannot persist your directories, like work folder with logs and some meta information. Now, let's explore the statefulset resource, and there are not many limitations for it. So I would say that a setup itself is a bit more complicated. You also have to mount your volume on disks and so on, and the start time is slightly increased in comparison to the deployment. That's why I recommend you to go with statefulset most of the time, regardless of whether you need to have a persistence or you are running a pure in-memory cluster. Now let's talk about how to structure your clusters in terms of the relation between statefulset and pods. And there are two possible options, as you might see on this slide. So multiple stateful sets with a single pod or a single stateful set that runs multiple pods. So in case of a single stateful set, there are following pros. Just more natural in terms of a resource organization, which means it is easier to configure and it requires less additional management. At a disadvantage, sometimes it might be tricky to follow this deployment, for example, in some multi-availability zones configuration. Now let's check pros and cons of having multiple stateful sets with a single pod. Well, this configuration simulates a well-known direct installation in a non-Kubernetes environment, where you have multiple VMs that runs your nodes. Also, it allows you to make independent changes to your nodes. And the limitations are also straightforward. As a result, we will have a configuration duplication, tricky management, and so on. That's why I recommend you to use a single stateful set resource with multiple pods. Now let's move on to networking and talk about how to access your cluster from outside of the cloud and organize your nodes discovery. On this slide, you might see a cluster deployed in the cloud and 3 different nodes trying to connect to that cluster from behind the net. A server, a thick client, and a thin client. And the question is, which node should you choose if you want to access your cluster? All right, as we can see here, a server node just won't work in this scenario. A thick client won't work out of the box, and the additional configuration is required. And a thin client will just work without any limitations. So here you can see the summary of this. And speaking of a thick client, you have to adjust the following environment variable. So force client to server connection. It is worth mentioning that there are some minor limitations related to this setup, like continuous query. Therefore, it is better to refer to the official documentation, to check the details. And the best node organization would be to put everything inside the same cloud, including your server, your clients, and your application. Now, a few words about the internal configuration. Since everything in Kubernetes is dynamic, there is no point in having a static discovery configuration. Instead, you should create a Kubernetes service that will register your pod IP addresses and a Kubernetes IP finder that will work with the service. So an IP finder will obtain the available internal addresses first, and then use them for communication. All right, here is the summary of the networking section. So I recommend you to put everything inside the cloud and use a thin client if you want to access it from behind the firewall. Regarding the cluster configuration, do not use static IP. Instead, configure the TCP Discovery Kubernetes IP Finder for your servers and thick client, and there is an additional IP Finder for thin clients as well. Let's keep going and discuss pod configuration. Here I mean some general recommendations related to the pods, like Graceful Shutdown and Liveness props. All right, let's start with Graceful Shutdown, or the so-called Apache Ignite shutdown hook. And the general recommendation here is always try to shut your nodes down gracefully, especially if it is some kind of maintenance restart. There are the following benefits of having a shutdown hook installed. So it waits and cancels ongoing operations like active transactions. It ensures data consistency and also ensures that sufficient backup factor is present and you won't have any lost partitions. Let's explore the last point in detail. Suppose we have 4 nodes with a backup factor set to 1, and we need to restart our nodes. In this case, we cannot stop more than a single node at a time. For instance, if the fourth and third nodes are being restarted at the same time, we are going to lose partition B, since there are no more backup or primary owners of this partition. That's why the shutdown hook will prevent Kubernetes from stopping node 3 until node 4 is back alive. Now, a few words about how Kubernetes handles pod termination. So when a pod is scheduled for termination, the Kubernetes ecosystem sends a termination signal to the pod. And it means the pod enters the termination state. So it is being removed from the service IP list and so on. Once the shutdown hook is finished, the termination process ends. But it is worth mentioning that shutdown hook execution might take a while, and Kubernetes has a special termination grace period timeout. It means when this timeout expires and pod hasn't been deleted yet, the Kubernetes will send a kill signal to a pod, which means like it is force killing the pod non-gracefully. That's why it is recommended to set this timeout to some big value. Here you can see how to configure the Ignite shutdown hook. So first of all, you need to define it using the XML shutdown policy property. And do not forget to set internal termination grace period to some big value. In addition, make sure that you are listening to system signals from within your pod. So for official images, for official Ignite and GridGain images, that works out of the box. But that might not be true for your custom images. So I mean, if you build them manually, just test them properly. So the next item is readiness and liveness props. Just according to their names, the liveness prop defines whether your pod is healthy. If it fails, the pod needs to be restarted. At the same time, the readiness prop indicates that your pod is ready to serve the traffic and is used for like initialization mostly. So imagine a situation where your node is starting up and is reading some world data from a disk. In this case, according to the Linus prop, your pod is healthy, but the readiness prop fails. And that is what you most likely want. Here you can see an example of how to configure the props for your StatefulSet. So we recommend you to use prop HTTP endpoint for the readiness prop and just version endpoint for the liveness prop. You should always define both of them to make sure that your cluster is working properly. Let's talk about consistent ID and why it is important to set it up correctly. So, consistent ID defines not uniqueness identifier that survives, not restarts. It mustn't be changed. It mustn't be changed, and its primary usage is for baseline and affinity definitions. So to define it properly, just set ignite override consistent ID environment variable to be read from the pod's metadata. Now, a few words about logging. Do not store your logs within a pod because it is difficult to access them, especially if a pod won't start due to some error. Instead, mount your work directory volume and use log rotation if required. Next, by default, most cloud providers come with a built-in logger that is listening for the standard output. This is why disable Ignite Quiet in most cases. And the best option would be to configure a dedicated logs aggregator like ELK, Kibana, or EFK to collect the logs. All right, the next item is dynamic provisioning and autoscaling. And here we are going to explore how to scale your nodes and how to perform an upgrade. Let's start this section with autoscaling and dynamic provisioning. And as a background, you need to understand that every Ignite node is a part of the baseline topology. So whenever you need to bring a new node or scale down, you have to change this BLT either manually or automatically. And every change to the baseline triggers data rebalancing. Therefore, you should avoid frequent BLT changes. Keeping the background in mind, I do not recommend you to use autoscaling because, after all, Apache Ignite is a database. That's why I prefer scaling manually on demand. If dynamic scaling is really required, make sure to use auto baseline configuration with some big timeout, so at least 10 minutes. And now let's talk about how to upgrade your cluster. In GridGain, there is a special feature called rolling upgrade that allows you to run different node versions in a single cluster and to perform an upgrade with zero downtime. Here you can see a screenshot from the GridGain control center with various widgets that helps you, to control the upgrade. To perform a rolling upgrade, the following preconditions have to be met. So you need to enable a rolling upgrade mode for your GridGain configuration. It is very important to verify that all other recommendations have been followed, like setting up the props, the graceful shutdown, and so on. And it is also important to test this behavior well before running on production. So to trigger the rolling upgrade, we need just to replace an image version and tell Kubernetes to trigger, the actual upgrade. It is worth mentioning that starting from 8.1 version, a special rolling upgrade mode was introduced that require like few additional steps. And I suggest you to check the documentation for the details if you are unaware of how does it work. So unlike GridGain Ignite doesn't allow you to run multiple node versions in the cluster, which means a maintenance window is required to perform an upgrade. And the simplest way, I think, would be just to deactivate the cluster to stop possible updates, scale down to 0, replace your image, and then scale back to the original value and wait for cluster auto activation. So it is like pretty simple, I suppose. Let's keep going. The next topic is multiple availability zones, and here I'm referring to the AWS regional division terminology, where a zone is just a dedicated data center. So why would you ever need a cluster that is running on different zones? Well, mostly to provide fault tolerance to your cluster and to provide a better data locality to your clients. So here you can see a cluster that was deployed in 2 zones. Most of the time, you'd also want to configure the backup distribution in such a way that the backups from one zone are always stored in a different one. Now, if a data center goes down, we still have all primary and backup partitions available for our cluster. As you can see on this slide, the backup partition from zone 2 now became a primary partition for zone 1, and our cluster was still up and operable, despite losing half of its nodes. A few recommendations of which availability zone to choose. So, do not stretch your cluster too far. Speaking in AWS terminology, stretching a cluster across availability zones within the same region is perfectly fine, but do not deploy your cluster across multiple regions because of network latency. A few words about the implementation. So the thing is, it depends on your cloud provider. So in short, you need to configure a Kubernetes autoscaler and also configure your backup affinity filter to check for a special availability zone environment variable. The complete implementation is beyond this talk, so I suggest you to check the official documentation for the details. So here is the summary. We use multi-availability zone deployment for fault tolerance and data locality. Prefer to pick near zones, and also it is worth mentioning that you shouldn't use a stretched cluster for backups. Instead, GridGain offers data replication and snapshot features that were designed specially for this. The next topic is disks and data. In this section, we will check what types of disks to choose and how Ignite stores that data. So as I mentioned previously, Apache Ignite is a database and it uses disk a lot. So let's explore the folders. So here we have Vault folder that records your updates, and mostly it uses sequential access, which means that throughput is important here. The next DB folder that keeps your actual data requires random disk access most of the time, and these are IOPS bound. The other folders like work, wall archive are not very important in terms of performance, therefore we can skip them for now. So the main thing is that slow disks might cause your cluster to freeze, especially if you are hitting some memory limits and there is an active page replacements and so on. So the simple rule, the more IOPS you have, the better it is. Therefore, my recommendations are, so for WAL folder, use a disk with highest throughput available. For DB, a disk with highest IOPS, and it is important to have different volume mounts for your WAL and DB folders. At the same time, it is fine to have a single mount for other directories. Also keep in mind that some cloud providers will place IOPS limit not only to the disk itself, but also to a node or machine to which it is attached to. So on this slide, you can see our recommendation in respect to the mostly used cloud providers. For example, for AWS, we recommend using provisioned IOPS SSD disks with maximum throughput of 1 gigabytes and 50 IOPS per every disk gigabyte. Let's keep moving. The next topic is GridGain Operator. So what is the GridGain Operator? Well, it is a special controller that is responsible for managing and running your Apache Ignite and GridGain clusters. So first of all, you need to deploy the operator, and then a user interacts with it by changing special custom resources. The operator is constantly tracking for custom resource changes and is adjusting the cluster state with respect to these changes. So you don't need to create and modify Kubernetes internals, Kubernetes resources like service, config maps, and so on manually. So speaking of the benefits, the operator provides a declarative way of cluster configuration. You don't need to take care of Kubernetes internals. It includes the previous and other suggestions that we have talked about, and it reduces deployment time and suitable for running both Apache Ignite and GridGain editions. So here is just an example of Ignite customer source. As you can see, you just tell the operator what say number of nodes you would like to have, which image to use, what JVM arcs you'd like to have, and so on. So how you would like to get it running? So you need to start by downloading and unzipping the operator bundle from the GridGain website and deploy it in your cloud provider. Then create or adjust customer sources and have fun. So there is a quick start guide available. So I suggest you to follow the official documentation. All right, finally, let's review what we have talked about today. And here is the conclusion. So use a single stateful set with multiple pods as your deployment model. Remember to configure consistent ID. Do not forget to set up readiness and liveness props. Remember about the shutdown hook. I suggest you to avoid dynamic scaling. Use fast disks with high IOPS value. Put everything in the same cloud if you can. Do this and also test your deployment well in your lower environment. Quite obvious suggestions. If you need an automation, check GridGain Operator. And you also might be interested in Nebula. It is a newly launched GridGain SaaS offering. All right, this is the last slide of the presentation, and finally we are done. Thanks a lot for listening. And if you have any questions, I'll be happy to answer them.
Hi, Alexander. Thanks very much for your talk. It's got some great feedback, backstage at least, and we have a few questions for you. Well, the first question has already been highlighted here by kind of Michael. Is there any storage difference when using Ignite with SQL versus key value store?
All right. No, there is no like real difference, I think, in terms of using Ignite in SQL or key value store. I mean, underneath, you will still have the same persistent model. I mean, you need to store your data in pages. I mean, there is a memory page model for GridGain, so you still would like to have, you still need to have random access most of the time.
Great, thank you. Just as a reminder, there are the virtual kind of booth at the side of the screen on the left. If you have specific questions that you'd like to kind of put to our experts. We're actually getting lots of questions through right now. I don't think we're going to have time to get through all of them right now, because we are running slightly behind schedule. So it's a compliment that your talk is getting so much feedback. But let's maybe go a couple more questions.
All
so
right.
The next one's from Aravind here. How to perform a clean stop and start the cluster? You mentioned about using SIGTERM. Currently, we perform it by restart by deactivating, deleting the stateful set one by one, and activating the cluster. Is that the right way of doing it?
Yeah. So I think the main and important thing here is to remember to deactivate the cluster. I mean, you would like to make sure that there won't be any unexpected changes to your cluster, unexpected updates. So when your cluster is back up and auto-activated, then there shouldn't be any rebalance. Because otherwise, if one or two nodes will receiving some updates, then other nodes should be aware of this and to restructure or rebalance the data. So yeah, I would say that it is a proper way to do this.
Okay, let's look finally at Rajit's question. Can you move down, whoever's selecting it, can you move down to Rajit's question, please?
When is Apache Ignite Docker image support? Oh, wait a sec. So which question do we really
So for persistent volumes, what do you recommend? NFS, Kubernetes local persistence, what's the best option there?
So I'm not quite understand what do you mean by local persistent volume. I mean, if there are, so yeah, most of the time you will deal with NFS, I mean, network attached disks. And if it's possible, to have a locally attached disk, then for sure it will be, just more efficient in terms of performance. There wouldn't be any network, hops and switches. You don't need to send your data over a network. But it also depends on the disk itself. I mean, so if it is about HDD and so fast SSD NFS, then I don't know. I believe NFS.
I mean, my experience is one of these really hard things. It varies a lot from cloud provider to cloud provider to kind of local installations as well. So it's kind of a hard question to answer. Just fast disk is the short version, I think.
All right.
So thank you for that. I understand Alex is going to be in the booth to answer a few more questions.
Yeah, I will be here a little bit later.
So thank you for that. I recognize there's a few more questions we didn't get time to get to. So I apologize for that, but you still have the time to look at those. As on the left-hand side of your screen, there's the option to go to the virtual booth. You're going to go there.
Yeah.
Our team, Alex and Michael and Rohit are going to be online to be answering your questions.